Yeah, yeah. Welcome all to this week 11 live session. So this is an second last session of this course. So in this session, we primarily discuss the questions about the effect of a small word network. In that, we'll discuss some that experiments has been done by the Milgrams and uh, other studies that we have seen, that is decentralized research and generative models, right? So we'll while discussing the questions, we'll also grasp or clear some doubts, or we'll also discuss that concept particularly. Okay. Yeah. Till now, is there any doubts or any questions? Okay, if not, yeah, we'll start from the first question first. Yeah. So this question is about the random, the generative model, how we can generate a model such that it can follow the small word effect. That is an that network is unconnected, and also any node, the distance between the any node has been average distance would be that is an average hops distance would be the 6, right? That we have seen in uh, that small word effect model, right, in this week content. So this question is about that in that is one factor, that is a rewiring, which is an related to the how we are generating the a graph, generating a more generative model that will generate a network which is an small, um, uh, which is an connected network, and which has an the hope distance between the nodes, which is an average, which is an 6 degree. And while generating it, it follows the two laws actually. The first is an that random that generative model is based it's based on the two principle. The first is an homophily and the weak ties. Okay. So let's see the first question. In the context of small word generative model, what does random rewiring refers to? So this is very simple actually. The generative model is based on this random rewiring actually. Whole principle is based on the rewiring. How you are uh, based on this rewiring, it follows the homophily and the weak ties concept. So anyone from the audience can give the answer for this question? Is anyone? So here, okay, let's discuss how generative model uh, will works actually, and in that how the random rewiring will done that job actually. How we are doing the random rewiring. So we have seen in small word generative model, that is, and there is an nodes are in represented in a circular fashion, that is an in circle fashion. Okay. And they are connected to that their neighborhood nodes, and also they are connected to two hops nodes as well. It is connected to this way. Let's take as an assumption like this way. Okay. So this node is connected to this node is connected to this node is connected this way. Sorry, this is and this node is connected to this node is connected to this one node is connected. Okay. So this is how the first step we have connected the node. The node has a joined or has established a connection between their local neighborhood. Local means there is an direct connection with the nodes which has an that locality of that particular node is an near to that particular node. That means you can see this node, it is connected to the their nearby nodes. Actually, this one in node and this one also, it is connected to this node and this node, right? So it is not connected to that far away nodes, right? So random rewiring. So here, that in small word generative model, the two concepts has been captured or modeled. The first is an homophily, and second one is an that weak ties, right? Weak ties. So you can see here the homophily has been conducted here. Means homophily is applied here. You can see that homophily means what? That in suppose they are clustered together with a similar property. Here they are clustered together means they are connected closely with the neighborhood nodes, right? They are, you can see this node is an neighborhood to this particular node, means it's near to this node, right? And it's not connected to the faraway nodes, right? So it is obeying the properties of the homophily, right? So but you can see there is no as such weak ties are there. So what random rewiring does, so it is removing some edges from this oral network, and that particular edge it is establishing into the far away nodes, in between the far away nodes. You can see, let's take a this node. So we are removing this node, right? Right. So we are removing this node, and then we are redrawing that remote edge in between any nodes. Not only we have to draw by this node actually. Okay, this can be drawn from this to this node, right? So this edge should be in between the faraway nodes. It's not as an immediate nodes has been drawn that particular edge, right? And similar way, you can remove the edges from the network, and that removed edge you can establish again established in the network. Again you can add in the network, and that you can add in the network, considering that edge should connect the far away nodes, right? So that is based on a probability how much, in which rate we need to remove the edges, and in which rate we need to add those edges in far away nodes. Okay, so this is how the edges will be removed and edges will be added. So the working of the steps I have explained as earlier, that represents a random rewiring. Actually, the random rewiring, what it does, it is removing the edges from the established network, removing the edges which has in that is in connected in a local nodes, that is in, means they are connected in neighborhood nodes. We are removing that node, that edge, and re-adding that node, adding again that edge in the network, and by that we are joining the faraway nodes, right? So you can see here these are the faraway nodes. So the concept, this is the working of the rewiring actually, right? I hope you guys understood. If you have any doubt, or you are not understood, please let me know. So here you can see the first option states that reducing the network to two communities, that we are not doing here. So guys, have you understood why we are adding that edge again into a faraway nodes? So you can see here that this edge is directly connecting to the this part of the network and this part of the network in a one hop distance, in a single edge, right? So this represents, it's not a strong tie, because it's not a we can say this is not a direct what we can say, the friends of this circle, friends of this users, it's not directly connected to this user, right? This particular user. So you can see these nodes are, the connection with these nodes by this node are strong ties, strong connection. They are close friend to that this user. but this age, uh, from this user, it's not a strong connection. You can see how we are saying that, or by which condition we are saying that that age isn't strong or not strong, based on their friends of friends, how many their friends of friends there it is connected. Means you can see, suppose it's this, so this node and this node is not connected to this node, right? That we are, so that's why only this node, from this side only this node is connected. That's why there is a no as such uh, communication will be done in this, in between these two nodes. Only some communications has been happening in this in between the two nodes. So this is an, this represents a weak ties. Right? So you can see here, in between these nodes there is a strong connections, right, that represents homophily. And there is some edges, these red edges, that we are drawing by using the concept of the random rewiring, that that will um, captures the weak ties property. So based on this, we are generating a small word network that has connected network as well. The distance between the any two random users, the distance is in 6 hops. Average distance is in 6. That is in experimented by the 1 second. Where is my pointer? Right. That is experimented by the Milgram's experiment, right? In that they have shown that uh, in distance between the any two random nodes is in 6 hops. Average distance is in 6 hops. Right. So yeah, the reducing the network, it's not like that. We are not doing as such task here actually. In second option, creating new communities in the network. So there is no as such communities we are creating here. They're not only we are establishing the ages in between the communities, we can say that. Okay, but we are not creating new as such communities here. So in third option, adding more links in randomly. It's not just adding links randomly here. Before that, we are only adding those ages that we are removed firstly. So we have removed suppose 5 edges, then we have added those 5 edges randomly in between the faraway nodes. Right? Likewise, we are doing the rewiring task, random rewiring task. Okay. In the fourth option, so this second option, third option is also not correct. Let's see the fourth option, what it says. Uh, Remove an edge at a random and add a new edge. Right. So this is the concept of the random rewiring, right? It is referring, that is we are firstly removing an age which is at random, and then we are adding that particular age in a network, so that the faraway nodes can be connected, right? Yeah, let's move to the another question. Till now, is there any doubt? Yeah. So in the second question, let's see what it says. Uh, Ignore for the time being that many of your friends are you as well. So the first statement states that ignore for the time being that many of your friends are your friends as well. That means I will only elaborate right now this part. What it states, suppose you have a friends, right? You have a two friends currently, let's assume that. Okay, and these two friends has, and uh, the two friends are there, two friends are there. Let's take this is and x y z a b c d, right? So here the a b c d, these are the x friends of friends. it's not a direct friends, right? So here they are in the first statement, they are stating that these friends are not direct friends to this X user. Right? There might not be cases like this way. Right? Suppose means it's not like that. There is an suppose C node is there. It's not connected to this C node because it states that they have given one assumption that the friends of friends, it's not a my friend, that is not direct connection with that friends of friends. It is stated in the first uh, statement. Okay. Yeah, let's move to the another part of the s- question. What it state, what it asked the asks for any solution. So if everyone has 500 friends, right, means it states that firstly the user has a friends, and it states that this user has a number of 500 friends, 500 friends. And how many friends of friends does a person have on average? Right? So there is an the question has given the firstly in the two levels. Means you can see, ignore the time being that many of your friends are your friends as well. If everyone has, means they have given like this way. So we have this tree like structure, right? And they are stating that each node represented in this two level graph, two level network, and each node has uh, 500 friends. So uh, considering these friends of friends, how many average persons are there, how many users are there, friends are there? So how we are calculating it? This is a zero level, this is the first level, this is second level, right? So the these are the second level users are friends of this user, this zeroth user. So we have to find how many users, how many friends of friends does a person have for this person X. Here we have taken person X, person have on an average. How we are calculating it? So these 500 users has, anyone wants to answer this question? Yes, anyone? Okay, fine. So here the 500, the first node has X user, that is a person that we want. His friends of friends, how many he has friends of friends. Then that for that we have drawn this tree like a structure, and the X user has an first of 500 their direct friends, their friends, and these 500 friends, the each friends from this 500, each person from this 500 users, 500 people, persons, has an 500 friends as well. You can see here is an 500, this node has an 500 users, 500 friends, this node has an 500 users. So likewise up to 500, n is equal to 500. So in total, how many friends can be possible here? So as we have saw in that um, I think generative model the migrants experiment in the lecture series, I already mentioned that how the each level number of users we can calculate. So here the number of users are 500. In the second level, the 500 users has their friends is in each node has an 500. Then the 500 into 500, that is a solution actually, the solution of this question, that is a 500 square, right? If it is in third level, then 500 cube, right? Because 500 squares, those users has in there, each user has an 500 friends, right? Likewise, so here The 500 into 500 is an total users are means possible users are in this second level of the network. Second level represents the friends of friends of particular person X. So here the 500 is not the answer is an 2,50,000, right? Okay, so that is an 500 into 500. Okay. Yeah, let's move to the another question. Which of the following is true for the watt strongest model? Right. So we have saw what exactly watt strongest model. Let's see what it states actually, what it refers to. Let's explore the options here. The first option states that network model with a fixed degree distribution. Network model with a fixed degree distribution. In this content we have not saw or we have not draw a network, a small word network based on the degree distribution. We have uh, we have focused or in experiment in 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 Milgram's experiment, we found that means Milgrams found that in their experiment that is an small word network. It's unconnected, and the distance between the two any two random users is average. Average distance is an six average distance, right? That has been validated by this Watts cross model, which is an they have simulated the this phenomena, and they have created a model based on homophily. They have observed that to draw or to generate a small word network, it requires of and uh, homophily and the weak ties, right? So because of this the network is unconnected, and you can reach the network, you can reach from any source node to the target node in a average 6 hops. So based on this referring this, let's explore the options here. The network model that degree distribution is not followed. The second option, nodes are added sequentially to the network, that we are not doing here actually. The squad squad model, word squad model, that we are defining a network, and from that we are doing a rewiring to obey the network which has an homophily and the weak ties. Okay. The third option, it states that homophily and weak ties are the two phenomena which give rise to small word network, right? So that has been found by the Watts-Scrotts model actually, and that these two assumptions, these two phenomena, they have used to generate a random generate a small word network, right, to simulate the network, right? So the fourth option, the triadic closure and the community structure are two phenomena which gives the rise. It's not like that. It's triadic closure. It's not shows the um, means these two properties, triadic closure and the community structure. That two properties tends to uh, or obeys homophily properties actually. It's not included a weak ties. Based on this triadic closure and community structure, we can't build a small weight network. You can see here that is an suppose these two network these three nodes are connected. This represents a triadic closure, right? And let's assume that we have also as an community structure. This is an community structure we have considered. So only considering these triadic properties and clustering properties, it's not enough to draw or to follow a small word network effect. To small means Wattstrong's model, they have found that to draw or to get a effect of the small word networks, we require, it follows, the real world network follows homophily and weak ties. Here we can say it follows the in the triadic closure and the community structure. It can considering this, we can capture the homophily properties here, but it not includes the weak ties properties. Right? It is not connected another network, another community which is far away. This node is far away from this node, right? So that will helps to connect two communities, and which will helps to rise, or it will be address the effect of the small word networks. Okay. Yeah. So here the option 3 is correct, which obeys or which follows, that is an homophily and weak ties are two phenomena which gives the rise to small word networks. Okay. Uh, yeah, in this question, you need to find out or pick out that idle value for clustering component to perform an efficient decentralized search in a 2D Watt-Squads model. So at the end of the session, we have drawn that a plot which is an distance and the k value, right? So k value we have considered here, and there is a 0, 1, 2, 3, 4, 5, and we found that for a value, a specific value of k, we found a distance from the nodes is an it gives an minimum distance, right? So that value is a specific value is an 2 value, which is a stable value. It gives an less distance, right? Less means comparative distance. That means suppose we are finding, we have a formula, right? That probability how much this node, this source node is reached to this target node, source node. What is the probability or probable to reach those node? How much probability to get to reach to this node? That is based on the distance, how much distance it requires. Based on the distance, we are getting a probability, right? So let's take as an suppose we are taking as four hopes. That is a four distance it requires. Four edges I need to pass on to reach to a target node. Likewise. So another example, there is an target two, which is an connected far away target two, and distance is an 10. So we have saw that the probability we have calculated, that is 1 divided by distance between the source and target node, and raised to k. The k role captures here actually. Suppose the k value we put as an 1, in that case the actual values you can see the 4 and the 12, the difference between these two values, it's too larger actually. And we have put it two values that is they found in the experimentation, in the research, that is an 2 is an constant value we can put there, and we will get as an uh, is an comparable distance actually, right? It's not as a far away probability we are getting. So here the answer is an 2. 2 is a stable value for the decentralized research. Yeah, let's jump to the another question. Select the factors that affect the spread of contagion. Right. So if any information is spreading, so we need to find out which factors are affecting to spread the network. The first option states that a friendship network across the world is completely connected. Yeah, that is true, but what is the factors are affecting the spread of the contagion? Right. So the friends are connected, but suppose friends network across the world is completely connected, but the distance between the one, suppose uh, you are connected, the whole world network is there here, right? And some nodes are from the US, and some nodes from the India, right? There is a strong connection, or strong connections in between, strong ties in between this India's connection and the strong ties in between this US uh, users in between them, right? But there is an weak ties are there, or so the distance is not captured here in the first option. The friendship network across the world is completely connected. We can take as in completely connected, right? But we suppose there is an only one node and it is connected to this, and this is node is connected to this, like this way. But the hope distance you can see here, it's too larger. Suppose it is an 1 million connections needs to pass on, then I can dish to that particular node, right? That is not we want actually, right? The spread of contagion, spread of information in this case will be slower. It's not as an a spread, contagion of the spread of the contagion is faster actually here, right? When see the 10 millions or any billion connections you need to pass on, then you can then that particular information will be reached to that particular target user, right? So only the connection, only the that network is connected or not connected. Only suppose the network is connected, and based on that we can say that the spread is contagion, the spread of the contagion will be affected. It's not like based on the connection it might be affected, but there is other factors uh, which are strongly affect the spread of the contagion, that we need to find out. Let's see the second option what it states. Most people are isolated in the real world friendship network. Suppose if we are considering the friendship network, and if there is an isolated node, isolated means it is a node, it is not connected any of the node, right? So this is our network, then there is one node is there, and it is not connected to any of the nodes. That is an isolated node. Suppose any information comes into this network. So this node can be, uh, how this information can be reached to this node? There should be an age, should be there, right? But there is no age, so it's not affect the spread of the contagion, right? Spread of the information, right? So that's why it is not correct. Let's see this third option. Any two people are connected in the friendship network with a small path length. Yeah. So they are saying that, yeah, let's assume that the network is connected. Now, they have seen that, I mean, they have stated here in this option that any nodes, any two nodes you can take from the node, and the length of the this particular two node should be, or it would be a small length, means it is smaller value or smaller hopes to reach that particular information to source node. Are you getting? So I will explain it again. Let's take a friendship network, right? They are connected to each other, likewise. So it is stating that in the third option, the friendship network, right? We have considered here, and we have to randomly select any two nodes, randomly select, and the distance between these two nodes, distance means how many edges I need to pass to reach that particular node. We can say in other words, that is an how many hopes I need to pass to reach that particular node, right? So it is stating that you can take randomly two nodes from the network, friendship network, and the distance of this particular two nodes should be a small path, a small length, right? So that is an most affecting the factor actually, right? If it is a distance is a too larger, that is, if it requires a 1 million path, 1 million edges you need to uh, mm, pass, or you need to go through that particular 1 million edges, then there is a too much time it requires. Some in some sense we can say that the information may loss in between the path as well, right? It's not affecting the spread of a contagion. In this scenario, the contagion will be not a faster way, will be spread, right? The information will not reach as faster, as faster way, right? So the option 3 is correct here. It stated that, as we have also saw this principle which obeys in the world real world network, and in the effect of the small world network, right? That we have saw the any two nodes from the real world network, small world network, which has a distance is in 6, average distance should be 6. So that is near about a small distance, right? So option 3 is correct. Let's see what about the fourth option, it is correct or not. Any two people are connected in the friendship network with a fixed path length. So anyone from the audience can give this answer. This fourth option is correct or not? What do you think? It is affecting the spread of the contagion, or what do you think? It's not affecting. Is anyone? It's very simple. If we fix the path, let's take this example. Suppose the k value is represents a fixed path value, fixed distance, or what we can say fixed path length. That is one thing, means it should be a two path, one path in between the two nodes, like this way. The fixed part maybe it's not a robust actually, you can say. The fixed value might be a larger, might be smaller in some sense, right? But in the friendship network it's not like that actually, and it's not uh, affecting the spread of the length, spread of the uh, information actually, contagion. As you can see, suppose that real world network follows this power law distribution that we have saw, right? Degree distribution of the nodes, which is an some users degrees less, those users are very high, and users degree with very high degrees, very high, those number of users, those number of nodes very low, right? So considering this fact, it should not be followed actually, but in this network the contagion will be the spread of the contagion will be uh, this affect though the spread of the contagion actually. The fix the part, it's not affecting the spread of the contagion actually, it's directly. But because you can see, if node which has higher degree, right? Some nodes are there only 1 degree is there, right? In that case it's not as it not follows uh, a fixed path. Fixed path means every node has an equal degree, right? Fixed path, any two people are connected in the friendship network with a fixed path. To follow this, it requires a degree of each node should be equal actually, and that is not possible in the real world network, right? Are you guys getting it? Means for suppose it's take as a fixed length, right? Fixed length means from any two nodes. right? So this is the thing actually. If you are not understood, please let me know, okay? And further, if the session the, after the session you found any queries, any doubts, in that case as well you can mail me, okay? Yeah, let's move to the another question. In a real world friendship network, ages which are not to your neighborhood and connect you to friends from a distinct regions represent. So it is stating that, I will explain the question here firstly. There is an real world friendship network is there. There is an of friends are there for this ex user, right? And this is the real world friendship network. Age which are not your neighborhood and connect to your friends from the distinct region, right? So these are the from the India. Let's take and some notes. This is an friend. This is an Y user. It is an living in US, right? And there is a one age from this Y. So it is stating that age which are not your neighborhood. So these are the ages that not we have to consider this age which is not neighborhood. This is from the far away node connected to your friend, connected to your friend from a distinct region represents. So what this age represents, what we are calling for this age, we are calling as an strong ties, or this age represents as an weak ties, or it is represented as a selection, social influence. Yes, second, put my charger. Yes. So anyone wants to give the answer for this question? Yes, anyone? This is very simple. That we have saw in initial lectures. What is an strong ties? What is an weak ties? How? What is an social influence? Right? What is an selection? Right? So here, okay, let's understand what is an strong ties here. Okay. Let's differentiate the strong ties and weak ties here. The strong ties, the friends that that is your best friends, right? The best friends are connected. There are distance between the age, or a distance between this user to this user is very low actually, right? They are usually communicating to each other. That communication in between the two users, the frequencies in between the two users is very high. So considering this, and there is another factor as well. So the friends of there is a common friends in between this user and this users are very high as well. So that means the users are here, 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 here. Is connected to these users as well, and also connected to these users as well. So that this age represents as a strong tie. Right. We can also find by this way as well. And the weak tie that represents this, there is a network, there is a strong connection in between this community, right? And there is a single age which is in between the two, it is joining the two communities, we can say that. And the communication, or the communication is not usually happening on this age actually. This tie is very, very low, weak actually. So it is connecting two communities, the weak ties, right? So here that this age representing, that is in faraway nodes, that is in connected from a distinct regions, that is connected to another community, this age that represents a weak ties, right? So the correct option is weak tie here. The age represented here, which is connected, it is not connected to direct friends, but it connects to a faraway nodes which are distinct regions. Okay, and it is an, let's assume it is an another community, then that age represents as an weak tie. Let's move to the another question. Consider a 1D Watts strong model. The network is portrayed as a ring or a cycle on n people, where each node is connected to a n nodes, right? N nodes. So I will try read it again. Consider a 1D one-dimensional Watt-Strong's model. The network is portrayed as a ring or cycle, right? That is an uh, cycle shifter, that is ring shifter node is represented, and on this the cycle there is an n people, n nodes are there. Okay, n nodes are there, where each node is connected to a k nodes on the left side and the k nodes in right side. So it is connected, this node is represented like this way, then this particular node is connected to the this node left side two nodes and right side two nodes, like this way. Okay, so for k is equal to 2, so here I have drawn k is equal to 2. For the k is equal to 2, if it is k is equal to 3, then it is connected to the another third nodes on the left side or right side. K is equal to, so for k is equal to 2, the network will contain how many edges? That we need to find out. Are you getting? The question is so simple actually. So as each node here is connected to a four other nodes, from the left side two nodes and the right side two nodes. Right? So it is forming the four edges, right? So it is forming, so that is an n edge, n nodes are there, it is connected to four other nodes from the network. So these are the edges, total edges, but the each edge we, so this is an total edges are there, but we can't call as a not a total, it is an more than the total actually. So this is an each node is connected to the four other nodes, right, from the network. Four edges are there for means each edge is creating the four edges, 1 2 3 4. So that's why we have put it 4 here, right? But you can see we are counting each edge as an two times. You can see for this node we are considering this edge, right? But while calculating for this edge we are also again considering this edge, right? So for counting a distinct or a single time age, we need to divide it by the 2, so that we are getting as in 2n number of edges for k is equal to 2. So n by 2 edges, this would be incorrect, because as calculated the total number of edges is 2n. not 2 by 2, right? And n square edges, this is also incorrect. The network has far fewer edges than n square. You can see the varies n to n and n square, right, which would imply a fully connected graph, maybe, right? So the exactly our in conclusion, our correct option is an 2n edges, where k can be an positive integer. Option 1 is correct here. Okay. So yeah, I hope you guys understood this question. So anyone wants to solve this question? It's very simple. That I have explained the probability formula, that is an 1 divided by distance between the source and target user raised to k. Based on this, only this formula you need to put the values, and you can calculate uh, the probability values. What is the probability of them being friends through a week time? Yeah, please try. Please take a time, 2 minutes, and try to solve this question. Yes, anyone has got the answer? Okay. So I will read the question. The distance between node P and Q in a friendship network is 20. If we create edges according to the Wattstrong's model, given k is equal to 2, what is the probability of them being friends through a weak tie? Right, weak tie. So there is a two nodes in from the friendship network P and a Q. The distance between, that is distance represents how many hops it requires to reach P to Q, okay, or Q to P, okay. So the distance is, sorry, distance from this node to this node is 20. 20 has been given, right? If we create ages, there is a ages according to Wattstrong's model, given k is equal to 2, what is the probability of them being friends through a weak tie? Means what is the probability of that, probability of P and Q gets friend to each other by a weak tie, weak tie. What is the probability of weak tie? Weak tie. Okay. So how we are calculating the probability? Right, the P is equal to probability, the weak tie getting the free tie is 1 divided by 1 divided by distance between the P and Q raised to K. Okay. K here we have used as a constant K, which is explored by the research, explored in the research. Right? Stable K, it represents a stable key. Right? So here simply we are putting the values here, that is an raised to K, which is an 20 raised to square, that is we are getting an 400, right? And which is about near about 0.2225, right? So this is the answer for this question. It 0.0025. Okay. Yeah, I hope you guys understood. This is only simple. We have considered a probability equation, and in that equation we have simply put the values of values has been given in the equation, in the question. Yeah, let's move to the another question. Pick out the network that does not represent the Watt-Strong's model. So, so look on these networks. What do you think? Yes, anyone? What is the what is the representation of the network from the Watt-Strong's model? Yes, anyone? Okay, so this is the first and second networks representation. This is and second. So in Watt-Strong's model, we have saw that network. So what do you think? This network is a Scotsman model or not? So it should be a weak ties which has a random rewiring should be there. Random rewiring means it is connected a node which is far away from that particular node. So it is connected the node which is far away from the node. It along with that disconnected a local neighborhood node. Right. So here you can see it is only connected to a local neighborhood which only allows or obeys the uh, homophily phenomena here. Right? So you can after another thing is that it is not has been done as a rewiring concept here and random rewiring, which is that the any two nodes which can connects to a far away network, far nodes means like this way. It has not be as such nodes are there. So networks does not represent that small model. So this network is not obeys or not follows the represents the Watt-Strong's model as actually. So it's not correct here. This one option is not correct. This one is means this option is correct considering this question. It is asking does not represent. Right? It represents, right? So this option is correct here. Let's see the second options, means third and fourth option. Here you can see the nodes are connected to each other, and it is and there is a rewiring has been done, and there is a weak ties are there in faraway nodes. In this also, and in this also. So these option one, option three, and option four are represents the Watt-Strong's model, but option two, the network represented in option two, it's not obeys or not follows or represented the Watt-Strong's model. Okay, ठीक है. Okay, let's move to the another question. What is the average distance between any two random nodes in a small word network? Right. So we have found that is in small word network there is an smaller distance in between the two nodes. So in the option you can observe which option is in very small, which option represents a smaller value. N N is a very large value. If it is the smaller network, we saw that there is an billions of nodes in the networks. In the real world networks are there. Okay, 1 billion or any greater than billion. Right. There is an in you can pick any two random nodes, and the distance between the any two random nodes is in six. Average distance is in six. We have found that is a small distance in between the nodes that we have seen in the lectures. Right. Th- Considering 1 million as an small wind, the distance average distance between the nodes, that isn't too high, that is too huge actually, right? Yeah, option, yeah, log n, which is an less than this n. Okay. N log n, which is greater than this log n actually, but we can follow as an log n as of now. Let's see the option fourth, it's an n square, which is also greater than this log n. So here the option 2 is correct. There is a small distance in between average distance and small distance. Okay, small distance is an log n compared to the other options. Yeah. So till now, so we have covered the 10 questions related to the small effect of the small word network. In this, we have saw a generative model, small word generative model, how we can generate it, and which phenomena we need to consider while generating a network which follows the small word network, which is an distance in between the any two nodes, which is an six hopes, average distance and six hopes, right? Also, we saw the how we can find the probability of a weak ties which can connect to far away nodes, right? And likewise we have thoroughly brush up your concepts that has been covered in this week lectures. So I hope you have understood the questions and their answers. uh, if still you have any doubts or any queries, you can ask me now. Yeah. If not, we can end this meeting actually. And after this session, if you have any silly doubts or any queries, you can ping me anytime on mail. Okay. So this is my mail ID. Okay, you can mail me anytime. Yeah. Thank you for the joining. You can leave this meeting now. Thank you.